So my next guest today is Bernd Dielacher from EVG Group. Great to see you, Bernd.
Yeah.
Thank
Hello.
you for coming in.
Nice to be here.
Yeah. So we're going to talk about a couple of things today, but we're going to start off with your wafer-to-wafer hybrid bonding.
Yeah, okay.
So tell us a little bit about the background to this and the process that you have and what makes it unique.
Yes, right. First of all, as we all know, the big driver behind this is AI. AI and all the scaling that is required for the chips. The traditional scaling is getting kind of to its end.
Yeah.
So you are getting into new type of integration schemes, advanced packaging, and that's where hybrid bonding is getting more and more into. Hybrid bonding is involved in production for image sensors since a long time already, but now it's getting more and more into these new integration schemes. And that's where we see also our future business in memory stacking, in type of logic to memory stacking, kind of advanced packaging regimes.
Right.
And that's the big driver. And what is needed actually that you have to connect these chips with interconnect pitches that are getting smaller and smaller and smaller.
Exactly. I was going to say that the geometries are getting smaller all the time, so
Yes.
it's getting difficult. So getting the alignment right is absolutely critical. But
Exactly, that's the most critical thing, to get the alignment, accuracy down. That's where we have our tools that are capable of doing alignment accuracies from the bond aligner down to 50 nanometers. We get overlay accuracies all over the wafer in this range nowadays.
Right.
And that's key to drive this further. And we are developing here our tools further, because we will see in the future needs for even denser
interconnects. And I mean, one of the key things to help you achieve that is you've got to have an extremely flat and well polished wafer to start with. You have to. What sort of spec are you looking for there in the wafer?
Yeah, first of all, it's the incoming wafer needs to be prepared well for the bonding. So it has to be extremely flat. It has to have the surface roughness that is below 0.5 nanometers.
Right.
That is not done on our equipment. So this is the wafer polishing equipments. Here, for example, we are partnering up with Applied Materials in these cases. But at the end, when the wafer is coming in, then it's on our tools the alignment accuracy, first of all, that you have to get right and accurate, but also a lot of other things. So wafers are coming distorted, so you have to take care of this. We have the capabilities to get also scale out effects under control and such things. This is getting more crucial for the future type of wafers. They can have kind of warpages, saddle-shaped warpages, and all these type of things.
Yeah, you'd have to watch out for warpage, of course. So, having developed the hybrid bonded wafer, then the next thing to do is take it through to the next step, which is going to involve metrology to measure it. So, you've also developed something along these lines.
Yes, exactly. That is what a recent launch that we have is actually a die-to-wafer overlay metrology tool, a dedicated one. Maybe I have to go one step back here. So I was talking before about wafer-to-wafer hybrid bonding, and we are also involved in die-to-wafer hybrid bonding processes. So we are not having our own die bonder, but we have equipment, the EVG 320, which is a preparation tool, so doing the plasma activation, doing the cleaning up front for such processes. And so we are involved in this regime as well. And now we're adding a new tool that is the die-to-wafer metrology tool, which can do an accurate overlay control of all dies in 100% inspection. So what we actually see nowadays, if the packages are getting more complex, then Also, the interconnect pitches are getting tighter, also in
yeah,
die-to-wafer
yeah.
bonding.
Yeah.
So you need at the end 100% inspection of the dies in order to get a perfect yield at the end. And so we have now a capability to get, or we increased the throughput very much here in order to allow this 100% inspection during production.
Okay.
And that's, yeah.
Okay. So yeah, I mean, because obviously, if you're doing 100% inspection, that takes time. So you have to make sure that you're getting your cycle times down to a low
Yes,
level. What accuracy are you able to get down to? What resolution are you able to get down to on your inspection?
A resolution that is so we do have a metrology tool as well that is dedicated for wafer to wafer overlay metrology. This has a higher resolution as the one that is targeting the die to wafer metrology, but that is very much sufficient for the accuracies current die to wafer bonders are able to place the dies. So that's and
Well, that's two very innovative new machines from EVG. So I want to thank you for coming in and telling us about it today.
yeah, welcome.